Hello everyone, welcome to another week of C++. In this particular video, we will be talking about inheritance. Inheritance as a concept. First, before we talk about any topic, we have to understand why we use it. What is the advantage of doing so? So if you think about inheritance, the main reason why we use it, reusability. So the reusability is the main reason why we go for inheritance. So if you think about similar things, for example, if you have bank account, okay, so it's going to be a customer name, customer ID, or it could just be the account number. So if we take this example of bank, there will be some kind of account number, name on the account, address, okay, date of opening, maybe current status, is this still active, is this account still active, and then the main thing is balance, right? What is the amount of money that is in this bank account? Okay, now when we talk about this bank account, it is not that simple, right? Not only do we have these features, we also have some actions. So we can withdraw, we can deposit, we can open, we can close the account. So these are some methods. So when you go to the bank and you want to open an account, they are not going to just open any account. They will ask us, what type of account do you want to open? So you have a savings and you have a checking. Okay, and there could be more. So usually there is just, you have to open one type of account. It is not possible just to open a bank account, right? So normally, if you think about it, nobody is going to be in this class, but everybody is going to be either here or here. In that case, we call this as an abstract class because there is no purpose to opening any type of a bank account. But for the moment, let's assume that you can open a generic bank account, or you can go for a checking or savings. Okay, if that is a situation where you could have a bank account, you could have a savings bank account, and then you could have a checking account. So if we assume that, okay, this is also going to have account number, name, address, date of birth, status, balance. It's going to have withdraw, deposit, open, close. All of the functionalities that a regular bank account has, these guys also have. So instead of writing the code 3 times, once here, and once here, we want to make sure that we write it once and then reuse it. So in order for us to be able to reuse it, so we go for this particular hierarchy. So when we say bank account, so this can be savings account or checking account. Okay, so there is inheritance. What does that mean? Once you define it here, your properties and methods are available in some way, shape, or form to all of your derived classes. So that is what it means. Just because we inherited, we should be able to use a withdraw method, deposit method, open and close methods in savings account and current account directly. No work is needed. Also, the constructors are also reusable. You can reuse those constructors. So you get all of those functionality. And on top of that, anything that is special for a savings account or a checking account, if there is something special about it, or if you have an NRI account, maybe there are special rules, there are special fields. Those are also, you can define them here. Whatever you have extra can be defined here. So you can inherit and reuse whatever is in the base class, and then you can also add to it. So that is the advantage. So now let me quickly go and write a bank account class, and then we can derive from that class. Okay, here you can look at the base class that I have. Sorry, let's see, where is it? Okay, here is the bank account that we saw in the whiteboard. Account number, name, I left out address. We have date of opening the account or joining, and then status. So let's look at our class. I have to add the balance here. Okay. So those are some of the fields, and then we have a couple of methods. Okay. So what I have here is I have a bunch of private variables. Then I have two constructors. In both constructors, I'm setting the account number to 0. So I'm going to be updating that. So here I'm capturing the current account number. And then customer name should be NM. And then date of joining. So as you can see, I have two constructors, one that takes no parameters and then one that takes 3 parameters. Then I have a display account info where I'm just printing out. So the one thing is active will tell us whether the account is currently active or not. So I am using an if condition there to see, is the status active or not active, and then I'm displaying messages accordingly. Then I have a method called open account. So when I do a constructor and create a bank account, basic information comes, but then I have to activate it. So in open account, all I'm doing is I'm saying whether it's active or not. So when I say close account, we don't delete it. We just keep everything, but we set the is active flag to false. Okay. So this is just a basic one, and then what I did was I used an object and tested all this, and everything seems to be working fine. Let's run this code now. So I didn't want to like record me coding this, the whole thing. So that's why I just made sure that I'm just capturing the derived class. So this is our base class. From this class, we have to derive savings account and checking account. Okay, so let's go to savings account. So when you derive, you put a colon, you say public, how you are deriving. So we are going to be doing a public, and then the name of our base class is bank account. Okay, and the same thing goes for checking account. So when we do this, immediately all the methods are available for us. We have open account, close account. You should be able to do all of that manipulation. So let's test that theory out. So if I were to do checking account and savings account, just updating the data here. So let's change the name of the objects also, CA and CA for checking account, BA, so this has to be savings account, so this should be savings account. Yeah, no matching constructor for initialization of savings account. Yes, so let's go. So we created the 3 objects. Now we are going to make sure that there are constructors that we can use. So when we go and have constructors here, let's look at the constructors that are available for our checking account, for our bank account. So we have the one with no parameter, we have the one with 3 parameters. Okay. So we want to reuse them. There is not much we are going to do. So we are going to be saying public savings account is going to come and take everything from bank account. Here we are going to be saying public checking account. It's going to derive from bank account. So I'm not writing anything in my constructor yet. So we just wrote the constructor without the parameter. So let's do the constructor with the parameter now. So when we write the constructor with the parameter, so the three parameters are going to be account number, int, account number, string name, and then it's going to be string, what was the third one? Date of joining. Okay, so we are getting all the information. Now we have to pass it to bank account. So when you're passing, you don't redefine it. You just give the name of the variable, not the type. Account number, name, date of joining. That's it. We passed it. Okay. We are not going to do any other change yet. Okay. At this point, we are not making any other change. So let's copy this and just change the name. And that should do it. So now we are not writing any code. We are not rewriting anything. We are just, this is just a way for us to call the base class. Now let's run it. $79.2. So I get the message, okay, there's a missing closing, okay, and then it's saying semicolon expected after class. So let us see, bank account. Oh yeah, I think I killed one of the brackets. Okay, so now that we fixed that parenthesis, my code is working fine. I am able to like call a bank account object with the open account and display account info, and then I'm able to do that for the checking account and savings account. Now let's look at the code for checking and savings. There is absolutely nothing in it. So how is it working? It is working because we did inheritance. We inherited the contents, the behavior of the bank account, used it as a template, right? So we are able to reuse all the code. Whatever is in the bank account, we are able to reuse that. That being said, if we try to access any of the private variables, that is not a big no-no, okay, because they are defined as private. So we cannot access private variables of the base class, even inside the derived classes. So that is a big no-no. So let's try that. So if I go here to savings account and I'm trying to say cout if I do like that, account number, it says it's a private member of bank account. So because it is private, it is out of limits. Okay, but if you have a public property like a getter or setter in your base class, you should be able to use that in your derived class. Okay, so that is okay, but if you cannot access private members of the base class even within the derived class. Okay, so the private members of a base class cannot be accessed through objects of that base class or through the class or object of the derived class. So it is just strictly private to be used within the class. So that is the error. Now let us say that we have a situation where we want to be able to modify something. We want to let the base class modify something. Okay, for example, balance. Maybe balance is a field that the derived class should be able to modify. We make it as protected. Instead of public, which means everybody can access it, or private, which means nobody except the base class can access it, if we make it protected, this field is accessible inside the base class and inside the derived class. So for example, if I say C out, okay, that's not going to be erroring out. Okay, we never used that particular constructor, so let's put it here. So we any line of code we write, we have to test it. So that's what I'm doing. It says balance is 6 point whatever. It's undefined, so it's just giving me that. So let's fix that. Okay, let's make balance as 0. It's bad to try to access a field that has not been already set. So we get balance is 0 over there, and that is good. So let's put an end line so it's not smushed here. Okay, so that is possible. So we got that one done. So we are able to access that value. We can add one more constructor. Okay, here maybe open account. In the open account, maybe we can take a parameter there. I'm just changing the signature, and then I'm going to make balance equal to starting deposit. In order for you to open an account, you should be able to give some money, right? So that's what I'm doing here. Okay, for close account, this should not be void, it should return double, because if there is any balance, we want to be able to return that. Okay, so what I'm doing here is I'm copying balance, and then I'm going to zero out balance. I'm going to set balance to 0. So when you close an account, you have to return value, right? So that's what I'm doing. So now that we have done that, we want to be able to make sure that we are calling the method appropriately. $200. So this one we are going to make it to have savings account, let's say 5,000 is the minimum, and then checking account is going to be 1,000 minimum. Run it. Oh yeah, here. So bank account will give 500. Let's run it. So where are we displaying balance? Let's put that in the display account info. Let's also add balance here as one of the fields. See out balance. And then I can say balance here. Let's run this through. Account balance 5,000. I see account balance 1,500. Okay, they have all been set properly. So the reason why we are doing this is we want to make this look as close to real life as possible. So we begin to understand what is going on. So constructors are here. We are using them to initialize the values. The only time we are able to like adjust the balance is when we open an account, when we close an account, and then when we deposit money or withdraw money. So we don't want to expose that field to outside of the class, but we want it to be freely available to our derived class. That is the reason why we made it as protected. So now that we have done that, what if we want to change? What is the opening? So to open an account for a checking account, maybe we should deposit at least 5,000, and maybe the beginning balance should be 10,000 for a savings account. Those kind of validations, if we want to be able to do, we want to be able to customize that based on the class. So this is for the bank account class. Let us say that we want the children of the base class to be able to override our methods. Okay, if you want to be able to override these methods, you put the virtual keyword in front. Okay, so when we put the virtual keyword, what happens is we are able to override the implementation. So open account and close account will be available to be modified in savings account and checking account. I have the base class open account as virtual void. It's accepting starting deposit, and then it is setting the balance to starting deposit and setting is active to true. Then I have the close account, which is doing a little bit more. It is returning the amount to be refunded, and it's setting the is active to false and zeroing out the balance in that account. Now, if we want to override these methods, we are using the virtual keyword in the front. Now let's go to our savings account and checking account. So in checking account, I am overriding open account. Okay, so let us say that the balance for savings account, the starting balance should be at least 2,000. So if we come into checking account, I have the same signature as the base class, right? Void. We don't have to say virtual here because this is the derived class. So here is where we are doing the hard implementation of our method. So we are saying void open account, double starting balance, right? So the situation is min balance is 2,000. That is the requirement that I'm saying that for checking accounts. So we can add this validation here. So you may be thinking, if we are going to be writing code here, how is that reusability? So we could get the best of both worlds. You can completely not use the base class method and write your own thing. Or you could just write the additional things here and then still call your base class. And let me show you how. So here we can say if starting balance less than 2,000. So we are just going to send an error message. Okay. Otherwise, if there is nothing else that is different, we can just directly say, I want to call bank account, : open account. And then here I can give starting balance. So now I'm calling it, but I have the validation inside my checking account because this does not belong to any other class. So there is reusability, but there is also the flexibility for us to be able to customize this method for our own use. So let's first test this. So checking account, if I give 1,000, it is going to error out and say, hey, minimum balance is required. But for bank account, no such problem will happen. So test case 1 will pass, test case 2 will fail. Okay. So let's run this. So with the $500 balance, I have an active account that is just a bank account. But when it comes to opening an account that is a checking account, it says minimum balance is 2,000. I hope you can all see that. Right here where my cursor is. On the right, you can see here, it says minimum balance is 2,000, so we cannot open an account. Okay. So what I'm doing is I just added one thing to my constructor, um, and I forgot to press the record button. So I added is active to false because I don't want it to have some garbage value when I'm using it without assigning it. So in constructors for bank account, I said is active to false. So you can see on the here, minimum balance is 2,000, so we cannot open an account. Okay, even though the constructor sent all this data and all these got set because of the base constructor, account balance is set to 0 and status is still inactive. Okay, so that tells me that our code works really good, and we are still keeping it at a 0 balance, and we are saying that the account is not active, and that is important. Okay, so we just saw how to override a method but still reuse some of the functionality. So we want to probably do the same thing for savings account, and maybe the requirement is going to be a higher starting deposit. So let's go to savings account. Okay, and then just do the same thing, change this balance to 15,000. Okay, and then let's change the error message, and then let's run this. It's exactly the same. So you can see second and third test cases are showing the status is inactive and balance is 0. Okay, now let's change this number so that it's not 1,000 anymore. So this is going to be 4,500, and this is going to be 25,000. Let's run this. Now it should pass. Both the test cases should create an active accounts for us, and that is good. Okay, let us see where it says balance is equal to 0. Okay, so let's run this code. Okay, so we saw how we can call the base class constructor and then the derived class. In the constructor, again, you can do your own thing here. If you have anything specific for checking versus savings, we could add those variables here. What kind? Savings and checking account. Let's see. Oh, we could do interest calculation. So if you think about a method, there is no interest calculation for base class method, but savings account have interest calculation. So we could just add that as a method here. Yeah, savings account. So we could say something like calculate interest, and that could be very unique just to our situation. So we could just create a private, and then we could say double interest accrued. Okay, so, and then we could also say double interest percent, because year to year the percentage might change for that savings account. So we could just set these. So maybe your constructor is a good place to set these. We could set interest percent, we could set it to 5.0. Then we could have a method called calculate interest. So this could be return balance times interest percent. So we could have something like this, and this might be a method that's available only for savings account, not for checking account. So we are just saying we want to know the total interest. Every time you call calculate interest, it's going to calculate the interest. There is not much intelligence in it, but at least it's just so we can learn that you can have your own method. Calculate interest, and then I'm going to ask to display information. Let's repeat this twice and then see what happens. Oh, our display method, we want to be able to write the interest accrued. So we can make this as a virtual function. We could update this display account info, or we could just create our own method here in savings. We could do this also. See out. So that way we don't have to write another method. So let's see. Okay, interest accrued looks ridiculous. Let's see. What is the amount? We have 25,000. Let's debug. What was the mistake? So we have 25,000 here. So let's come in here, see what happens. Why is it not picking up a breakpoint? Okay. balance times interest percent. What was interest percent again? We set that to 5. Shouldn't be 5, 0.05. That's why 0.05 is 5%. So let's run the code now. Interest accrued is 2,500. If you call this a couple times, then you can see the interest accrued will keep changing, right? So we have 2,250 first time, and second time it is 2,500. You can see here. Oopsie. So first time is 1,250 interest accrued, and second time it just doubled because we called it twice. We are not updating the balance, we're keeping that separate. So you could have your own method just for your derived class. You don't always have to use everything that is in the base class. You can modify what is in your base class by overriding that in your derived class. So the way we did the override, right, that is called as polymorphism. So you have one function, but it is behaving in different ways. So that is what is called as polymorphism. So if you see the materials that I posted, you would see inheritance and polymorphism. Polymorphism is when one method by one name behaves in different ways. So in order for you to be able to override a method, it has to have virtual as the keyword in front. And then the other major thing that you want to think about is protected and how it is used. So again, you can have your getters and setters here. They will all behave similarly. And because they are public, you should be able to access them in your derived class. So we could just try one out. Balance is protected, so let's use something else. Maybe we can use balance. So if we had methods like this, we had property like this, the getter and setter, they should be accessible from outside here, from these objects, and also from inside your checking account and savings account. So for example, we should be able to do I can say SA dot get balance. And this would be perfectly valid. So you can see the last line, get balance, that property or the getter and setter, they will work no matter what because they are anyway public. So they are available even outside the class. So that's nothing different for this situation. So if you go into this week's, I have the materials posted here. I did not touch upon the multi-level inheritance and multiple inheritance for this particular exercise, even though it is good material to read. So C++ is one language that supports multiple inheritance. Multi-level inheritance is, you have father, like you have animal class, from that you derive the dog class, and from that you derive, dachshund maybe as a class. So that is called as multi-level inheritance. When you talk about multiple inheritance, it is like having two parents. So you have you could belong to animal, your dog could belong to animal class. It could also belong to an adoption center, maybe, you know. So it could, because it is, both are true. Adopt can be adopted, a dog is an animal. So they both can be, it can inherit from both. So there's nothing crazy about it. When you have like multiple inheritance, it's just comma separated. Instead of saying public animal, you would say public animal, comma, adoption center. And then, the same rules apply for what can work and what cannot work. And then we talked about access specifiers, which is the private, protected, and public. We have seen private and public before, now we have protected. And then C++ polymorphism, we talked about where in order for us to have one method behave differently, the approach we take is to make it virtual in the base class. So we could override completely, or we could, modify it without affecting the base class. We could still reuse the base class method, at least partially. So that is what we saw. In terms of the lab, the way we want to do is, we already have an animal class. We want to make a few changes to animal class. We are adding a protected member, and then we are going to be adding a method so that the protected member is accessed and used to modify things. Then we have two methods, one speak, one called feed, and constructor changes. Then you have to add a new class called dog and inherit from the animal class. Again, we are going to be setting a few variables. Some of this is more revision work for you, and then we are going to be overriding the speak and the feed methods. So remember to set, anytime you want to override in the base class, override in the derived class, your base class should set that function or method to virtual. Okay, hope this makes sense. And I think that's all we have for today. Have a great day.